All right, chapter 4. This one, we're going to take our time. We're going to do 2 sections each day. So I don't want to go too fast because there's a lot of stuff in this chapter and it gets more complex the further we go in there. For example, what is a polynomial? What does poly mean? What is that? Exactly, very good, very good. Poly means many. Nomial could be a number or term. So a polynomial is an equation with many terms. If it only has one term, what's it called? What's the Greek word for one? Very good. Monomial. Mono means one. If it has 2 terms, what's it called? Binomial. If it has 3, if it has 4, quadrinomial. Quad means 4. And anything after that, we give it a number and another name. We say it's a, so for example, this one has how many terms? It has 7 plus the constant. It has 8 terms. So we call this polynomial of degree 7. The degree, when you see the word degree, that refers to the highest exponent in the equation. We talked a little bit about this earlier in the semester. What does a degree tell us? Now, okay, you can determine that. Yes, okay, I know what you're talking about. The degree tells us the maximum number of solutions. Solutions are x-intercepts. So a degree tells us the maximum number of solutions. The degree minus 1 tells us number of vertices, or high and low points. So when we talk about like this one here, the degree is 7, we say n is 7. Because whenever we see that in the polynomial, it tells us we'll have at most 7 solutions, and n minus 1 equals 6. We'll have n minus 1 vertices. So the degree is represented by n. Now, here's another thing that's hard to believe. No matter how big or how small the polynomial is, the leading term dictates the whole polynomial. It tells us the shape, the direction, the number of answers, all that stuff. So that's called the leading term. It's the term with the highest exponent. Highest exponent. Let's look at some examples and let's dissect it, see what it tells us. So here we have tell me where what the leading term is, the degree, and the leading coefficient. So what's the leading term? 4x squared. 4x squared. It's wherever the highest exponent is, that's the leading term. So what's the degree? 2. That's the exponent. What's the leading coefficient? Yes, it's the coefficient of the leading term. Same thing, same three questions. The leading term, the degree, and leading coefficient. What's the leading term? 3. Very good. What's the degree?
1.
Nope.
0. Nothing.
Because why is it 0? What's the x? If it had an x, but it has 0, so it's not there. If there was an x there, then it'd be 1 or whatever number. But since there's no x there, the degree is 0. And the leading constant or leading coefficient
3.
is 3. One more. term, degree, leading coefficient. Leading term.
1.3x.
Right, there's the highest exponent, so that's the leading term. So whenever you have a polynomial, the first you always put it in decreasing order from the highest exponent to the lowest, because you'll have some questions like this on the homeworks and tests. So the leading term is 0.3 x to the fifth. The degree is leading coefficient. (0.3). The coefficient is the number in front of x. Because today, at the end of today, I'll be able to give you any of these type of equations, and you tell me what it basically is going to look like, what the graph's going to look like. Everything. Good afternoon. The behavior of the graph of a polynomial function is determined by the leading term. The degree, leading coefficient, and leading term, coefficient, and the leading term. Yeah, so there. The degree and leading coefficient tell us a lot. When we say behavior, that's how the graph bends and moves. It all depends on the leading term. What else? What other part of the equation can tell us some information? What can you tell me just by looking at this? What can you tell me about it? It's in standard form, yeah. But what else can you, what can you tell me what the graph's going to look like? Parabola. How do we know it's a parabola? Because it's degree 2. So we know our graph will look something like that, or like this, or like this. How do we know it opens up and not down? Right, because the leading coefficient, a, because remember, it's ax squared plus bx plus c, because a is positive. Because a is positive, it opens up. We also, because it's degree 2, we know that both ends point the same direction. What else can you tell me about the equation, about the graph of the equation? Do we know any points on there? That's the y-intercept. So we know that the graph opens up, it crosses at -3 on the y-axis. Now, if we solve it, and set it equal to 0, what can we find from there if we factor it? What do we do at this stage? We find that get the solution, so we set both of these equal to 0. So what are they going to equal?
103.
So what do these represent? What's another name for solution? X-intercept. So now we know the y-intercepts and the x-intercepts. And the y-intercept is at -3. We know it opens up. We know that both ends point the same direction. So we're already picturing the graph already. Yes.
Is there a problem with the protector or something?
I don't know. I don't think so.
Okay, cool.
I haven't had any problem with it. Thanks, sir.
Roger.
No worries. Thank you. So at -1 and +3, those are x-intercepts. At -3, we have a vertex. Do we know another point here somewhere? Since our x-intercept, if we go over 1, down 3, we have a point. From this side, no, it's not gonna be the same slope. But we know that because it's symmetric, it's a parabola, it's a mirror image. No, you go from here to here. Because this one goes, because somewhere between these two has to be the vertex. So the vertex is going to be halfway between there. So if I go to the right towards the axis symmetry, I go over to the right one, down 3. So that means I go to the left one, down 3, I have another point. Because it's symmetric. How do we find the vertex? Vertex is a point. -3 is a y-intercept. What formula did we learn about the vertex last time? It's the first part of the quadratic formula. -b over 2a. And then whatever we get there, we plug it back into the equation to get the y value. So in our equation, it was x squared minus 2x minus 3. What are a and b? 1, b is, so negative of -2 over 2 times 1. 2 over 2 is 1. What's the y value? We take the 1, plug it back into here. Our x value is 1. So 1 squared is 1. 1 minus 2 minus 3. So that's -1. Is that -4? So at +1, -4. That's where the vertex is. There's our graph. We're building these things up piece by piece by piece. All right, let's look at another example. For this part of this chapter, I will give you the factors. There's a polynomial. What can you tell me about this graph? The degree is 3, so what does that tell us? Well, we'll have at most 3 solutions, but what's the graph going to look like if it's degree 3? Yeah, and we know A is positive, so the graph will look something like this. Because it's an odd degree, both ends point opposite directions. We also know that our y-intercept is a -12. So the factored part of this thing, if we were 3 days in advance, we would be able to figure this out. Those are the factored forms. So what can you tell me about those? What is that going to tell us? Yep, the x-intercepts. What are my x-intercepts going to be? Right. And my y-intercept is at -12. Two, three, 4. So -4, that's 1. -1 has another. And I'm going to say that's -12. We're going to get to a point where now that we have it, once we have the factored form, we know the basic shape of it. We know that since this end goes up, this end has to go down because it has to have that shape. A is positive. What happens in between here? Well, that has to be a crossing point. How many vertices can we have? 2 vertices, because vertices is n-1. The degree is 3, so we'll have 2 vertices. So that means it has to cross through there, cross through there, cross that one, and go up like that. So there's a rough shape of the graph we have. So let's look at what we can find here. Let's see if we can talk about the zeros, the x-intercepts, the y-intercept, the max, the relative max, relative min, the domain, and the range. We should be able to talk about all of those. What's the difference between zeros and x-intercepts? They're the same thing. The only thing different is the way they're written. Zeros are, in other words, the x-intercepts we know are what? -4, 0, 1, 0, and 3, 0. No, for the x-intercepts, the y has to be set equal to 0, and we solve for x. So all of these y values have to be 0. So those are These are the actual locations of, those are x-intercepts, locations of where it crosses the x-axis. Zeros are simply thus just the numbers that if I plug those into the equation, it's going to equal 0. So that's the difference. Zeros are just the numbers themselves that when I plug them in there, it gets 0. X-intercept is a solution. So the y-intercept is at 0, -12. So let's say we have a point here at -2.510, and we have another point here at 1.5 -15. The relative maximum. The reason it's called a relative maximum because we have two extrema points. This is the maximum only for this part of the graph. Is it the highest point of the graph? No, because it keeps on going forever that way. Yeah, so that way, this one can't be the maximum, so it's only relative to that part of the graph. So what's the relative maximum? It's 10 at -2.5, at x equals -2.5. Because the relative maximum, you have to tell me where it's at. And the relative minimum would be what? No, at x equals 1.5. So when x is 1.5, we have our lowest point. What's the domain? Yep, because the graph keeps on going both directions. How about the range? Yep, because there are no stops anywhere. So far, so good. So again, we can answer all of these just by looking at it. Once we learn how to factor them, we can get more answers out of it. We can get more precise points. Polynomial versus non-polynomial. Let's look at the graphs. A function is a polynomial is a polynomial if it is continuous and smooth. What does continuous mean? Yes, without interruption. In other words, if I start at one end of the graph and keep my pen on it, it'll never lift up without any interruption. Now, what does it mean by smooth? No sharp points. Yeah, like that. No sharp points. If we have a point, it's a curve. Because it has to be smooth and continuous. So let's look at some examples. Some polynomial functions. Parabola, the cubic function, the horizontal line, a larger order polynomial. This should be x to the sixth power, or 6 degree 6. So all those are examples of polynomials. So what would an example of a non-polynomial be? What kind of function? What's the absolute value of x look like? It has a point, so it's not a polynomial. It's a function, but it's not a polynomial function. Square root. Because it's not continuous. It has a beginning and an ending point. One over x. It's not continuous. One over x squared. It's not continuous. So those are examples of non-polynomials. So far, so good. The leading term test. The leading term test. Remember, degree, we call it n. So let's say this is an nth order polynomial. That's the degree of the polynomial. So if the degree is even, what do we know about it? If the degree is even of the polynomial, both ends point in the same direction. What do you think makes them point different directions?
Different on, right?
These are still even degrees. They're both even degrees because they point in the same direction, either up or down. No. That one's the leading coefficient. If it's positive, it opens up. If it's negative, it goes down. Same thing here. This is x to the fourth. This is negative x to the fourth. If n is odd, both ends point in different directions. if n is odd, both ends point in a different direction. This is a cubic function. This is a negative cubic function. So the degree tells us which shape direction our graph's going to have. This is what's called end behavior. It's called end behavior. Where are the ends going? This is determined by the leading term. Let me put the chart up for the leading term. Actually, I can put it down here. While you guys are still writing. This is my degree. If it's even or odd, if my leading coefficient is positive or negative. If the degree is even and the coefficient is even, we know that both ends point up. We don't know what happens in the middle, though. You can have a bunch of squiggles. If it's even degree and the leading coefficient is negative, the coefficient is negative, then it points down. If it's odd, the left goes down, the right goes up. And if it's odd and A is negative, then the left goes up and the right goes down. Okay. Answer these. Okay, which one do I want to use? So roughly sketch this graph. Tell me everything you can about it and roughly sketch it. So what all can you tell me? What's the degree? Okay, so you want the y-intercept. The y-intercept is 0, -8. Do you know the x-intercepts? How do you know that? The only way you can tell me the zeros, the x-intercepts, is if you factor it and set that equals 0. So what goes here in the first space? What signs?
Positive, negative.
Yeah, because the second sign is a negative, they're opposite signs. The bigger number gets a negative. What times what is 8 when you subtract them, you get 2? 4 times 2. So the bigger number, so 4 goes here and 2 goes there. So my x-intercepts are where? So it's at -2, 0, 4, 0. What are my zeros? -2 and 4. What else can you tell me? Right. And behavior, same direction. Which direction is that? Up or down? Why? Right. They both go up, so we know that. So at -2 and 4, we have, so we know that goes up. So we know the graph here has to look like this. We know the y-intercept is at -8. So it's 1, 2, 8 down, 1, 2, 8 down. So where's the vertex? What's the axis of symmetry? This is also the axis of symmetry. -b/2a. So b is what? -2/2 times a is 1. So 2/2 is 1. So at 1 is the axis of symmetry. That's where the vertex has to go. On that line. How far down? Plug this back in the equation, what do you get? We have x² minus 2x minus 8. If you put 1 inside there, what do you get? 1², 2 times 1 minus 8. 1 minus 2 minus 8, -10 plus 1 is -9. So there we have it. There's the graph. Because we're going to start building up on these, making them much more complex. Are 2 and -5 zeros of the polynomial p of x. P of x equals x³ plus x² minus 17x plus 15. So how would you, what would you do to test them to see if there are zeros? Are 2 and -5 zeros of that? When we say zeros, those are also x-intercepts. So what if these were x-intercepts and you plug them into the equation, what will the answer equal? Remember, x-intercepts are the numbers, comma 0. If you plug this number into the equation, it should equal 0. So that's what's happening. If these are zeros and you plug this back in the equation, it should equal what? 0. That's why they're called zeros. So you have to test both of them. So work it out. Tell me which one's which, if either of them even. So we plug 2 back in there. So P at 2, I mean, you guys should be doing this because on the homeworks and tests, anything you'll be doing yourself. Don't bobblehead. Don't look at my stuff all the time. There's no bigger waste of time than doing that. This is why when if you're in here, might as well do it yourself and then check my work. Do the same thing for -5. So find the zeros of this. Set them equals 0. Yeah. Now do this one. Yeah. So my zeros are. Right. These 2 examples will lead us into another thing called multiplicities. Since we know the zeros are -1 and 2 of this polynomial, what's the degree of the polynomial? No. No. He said it was 3. It was wrong. The degree. Well, first off, when you find the degree, multiply the x's. How many x's do you have? 1, 2, 3, 4. You have 4 x's. The degree is 4. Since the degree of this polynomial is 4, what does it tell me about the graph? It's even. So what end behavior, where does it point? The same direction, they both point up. So this end has to go up, this end has to go up. One way you determine the degree, what are the exponents of these parentheses over here? They're all 1, right? If you add up all the exponents, what do you get? If you add up these, what do you get? So that's what the degree is going to be. If you add up all the exponents, that's what you have of your solutions. So these also tell us that the graph will look something like this. Because of this 5-binary thing, it's going to have only 2 x-intercepts. It's a degree 4. Degree 4s look like this, because we have 3 vertices at most. So this one is going to be pretty squished. You see it now? Now, on this one, what's the degree? It's also 4. 2 plus 2 is 4. 1 plus 1 plus 1 plus 1 is 4. So again, it's pointing in the same direction. This time it's pointing where? It's going negative. So we know we have the intercepts at -2 and +1, and they have to point down. I know that the graph will look something like this. Why? How come this one doesn't go up here and this one goes in both directions? Well, start piecing it together, looking at it. What's different between those two equations and those 2 graphs? Okay, now that tells me the directions, but why is this one crossing the x-axis? This one's not crossing the x-axis. Nope. 5 is a constant. It doesn't do anything. If it was positive, it'd do the same thing, just going up. What's different about those 2 equations? Not the graphs, but the equations. Nope. No, I mean that's 1 because there's only one of those equations there. They're both degree 4, but this one, it crosses at those x-intercepts. This one only bounces at them. Why? The only difference are those. If these are called multiplicities, whenever you factor out your answer and you have multiple of the same answers, the exponent tells you the multiplicity. If the multiplicity is odd, then it crosses the x-axis. If the multiplicity is even, it bounces off the x-axis. So after you factor them out, if your multiplicity, if you're in the parentheses in your factored form, if the exponent is odd, then we know the graph is going to cross through that x-axis at that point. If it's an even, then we know at that point, wherever it's going to bounce off it. It's not going to cross it. All right. Here's the next one. This one you can factor out. We've done something like this before. X cubed minus 2x squared minus 9x plus 18. Factor that out and roughly sketch the graph. We have 4 terms. Last week, we did something called grouping. Put the first 2 in the equation and the second 2 terms in the equation. That's the only thing we know so far how to do with polynomials larger than x squared. The first parenthesis, what do they have in common? X squared. So I take out an x squared, that leaves me with x minus 2. What does the second one have in common? A negative 9. If I take out a negative 9, if I take both of these and divide by negative 9, I just have x minus 2. Whatever's in the parentheses stays in the parentheses. The coefficients go in their own. What can you do with this? We also did it last week. X squared minus 9. We're looking for the factored form. We're not looking for solutions just yet. That's only one word. It's the difference of 2 squares. This is also 3 times 3. Review your notes. Again, you can't learn math by watching me do it. It's been 5 days since we did this. And if you didn't look at it, of course, you're not going to know what you're doing. You're wasting your time. You have to spend your time doing the homework, looking at the notes, reviewing your notes. Why else take them? You'd do just as good just sitting there playing with your cell phones all this time while I'm talking, unless you look at your notes. Everything we did so far that you guys are stuck on, we did last week. Should be nothing new. So what are my zeros? What's my degree? What's the exponent of this parenthesis? Add them up, you get 3. So what does all that stuff tell me? What does it tell me? What's the graph going to look like? No. Okay, because it's an odd degree. We know the ends have to point different directions. Is it going up or down? Is it like this, or is it like this? Right, because it's the coefficients are all positive. We know that this one has to go down, this one has to go up. Will the graphs cross the x-axis or will they bounce? Yeah, because all the exponents are odd. And it has to cross at positive 18. That's what it's telling me. I told you, this is going to be the hardest chapter. And if you guys don't review your notes, you're going to be lost. You're going to be stuck. This is what's called quadratic in form. It looks like this. Because that exponent is 1. So how do I get from this one to this one? I multiply it by 2. Is that how it works here? Do I multiply by 2 to get the first one? Yes. If that's the case, then it's quadratic in form. I can solve this the same way I do my other ones. When you factor this one out, the quadratic one, what goes here? X and X. It's whatever what goes inside your equations, and even the quadratic formula. You always use the middle, the symbol of the middle term. It's just X. So with this one, what would go here and here? X squared, X squared. And if you use the quadratic formula, you would use X squared equals the quadratic formula. It's whatever the B value is what you're solving for. The X of B. So what does this tell us? If it's negative, it tells us Opposite signs, the bigger one's positive. So what times what is 45? When you subtract them, you get 4. 9 and 5. 9 goes in the positive. Now what do you do? Why do we factor these things? What are we looking for?
0, right?
Yeah, the zeros, the x-intercepts. Yeah, so what do we have to do now with these? Anybody? It's not a difference of 2 squares, it's a sum, so you can't do that here. Good try though, but no. What do you do with both of these? Once you factor them, what do you do next? Set them equal to 0. And solve for x. So in this first one, we have x squared equals -9. We subtract 9 from both sides, move it over. Same with this one. X squared equals +5. Then what do you do? You're solving for x. What do you have to do next? Nope. Square root both sides. Since you square root something squared, what happens on the right-hand side? Plus and minus, very good. Do that to both of them. Plus or minus square root of 5. This one has a negative inside there. So what happens to that negative? The square root of a negative is what? Very good. And the square root of 9 is 3. So it's 3i. So those are your first two. So they're imaginary, which means those are not x-intercepts. So they're not zeros. These two, on the other hand, are, since they're solid numbers. The square root of 5, just a little bit above 2. The square root of 4 is 2. So square root of 5 is like 2.1, 2.2. So that means our graph would look like what? Since it's quadratic in form, it crosses at negative square root of 5, positive square root of 5. And it goes down to negative 45. Because these do not contribute anything. So whenever you solve these things and you have this negative inside the square root, that's an I, plus minus some number I. We only want the real numbers. Okay, that does it for section 1. Section 2 deals with graphing polynomials. Let's graph this one. By looking at it, what can you tell me about it? It's what? It's degree 4. So what does that tell me? The degree doesn't tell us that. What is degree equals 4? What does that tell us? The basic shape of the graph will look like what?
Okay.
Well, the point the same direction. Is it up or down? The coefficient is negative, so we know the graph will point something down. And they point the same direction. What's the y-intercept? Zero. So it crosses through the origin. Can you factor this? Do they have anything in common? They both have 3 x's. If I take out 3 x's, I have that. So what do these find for me? These are my factored form. Now what do I do with them? Once you factor them, what do? Set them both equal to 0, right? Once you factor them, then you set them equal to 0 because you want to know what the intercepts are. How do you get rid of the cube? Cube root. Whatever that is, that goes in the root. We do it to both sides. So x equals 0. Basically, whenever you have a constant x by itself, it's a 0 automatically. And this one, I could add 2x to both sides, so I don't have to worry about changing anybody's signs. And divide by 2. So x is equal to 0, and x is equal to 3 over 2, or 1/1/2. So we have a 0 at 0 and 3 over 2. What happens at those 2 points? Remember, we know it's degree 4. So both ends have to point the same direction. Because it's negative, they both have to point down. What we have to look at, since we know these intervals, and we know this one, we know this. From -infinity to 0, the graph will be below the x-axis. So any number we pick below there, if we plug it in the equation, we'll get a negative answer. How about between 0 and 3 over 2? What happens between there? Is it going to be above or below the x-axis there? Well, we don't know yet. Well, we do know because when we factor these out, they're both, the multiplicities are odd, which means they have to cross. So if we pick the number between these intervals, between here and plug it in the equation, we'll get a negative answer. Between these two, we'll get a positive answer. And between these two, we'll get a negative answer. These points here, the 0 and 3/2, those are also called our critical values. Because at those points, either to the left of them or to the right of them, the answer of the points will be either above or below the x-axis. For example, if we chose to use x equals 1 in the equation, if we plugged in 1 inside of x, what do you get? 1 to the 4th power is 1. So we have -2 plus 3 equals +1. So at 1, our answer is 1. Then we also have to check at 1/2. So we have to find more points, because now, since we know we have a 4th order equation, we have to have some movement up there. So that is what this next part's going to be about. How will it look? Will it go up like this? Will it go up or back down? That comes by picking up points. Let's try another one. G of x equals 2x cubed plus x squared minus 8x minus 4. Give me a rough sketch of that graph. What method are you going to use here? Grouping. If grouping doesn't work at this stage, then we can't do it. Like the next one I'm going to give you the factored form, because it's a 4th order equation. So what can we factor out of the first one?
Right.
Leaving me with
Right. Okay.
whenever you factor something out, divide these. So 2 x's are gone, so we have 2x. X squared divided by x squared is 1. There has to be something in that location. What can you factor out of the second one? If there's a negative here, you have to factor out a negative. And they both have a 4. So if we divide by -4, both of these, so that's positive. 8 divided by 4 is 2x. Negative and negative is a positive. 4 divided by 4 is 1. Whatever's inside the parentheses, and then the coefficients. What can you do with this? Is it anything we discussed last class? The difference of two squares. Is 4 a perfect square?
Yeah.
What's it made up of? 2 and 2. So since it's x squared minus 2 squared, I have x plus 2, x minus 2. That's the difference of two squares. So what are my zeros? -1 divided by 2. So yeah, it's the opposite sign, and this goes on the bottom. Right. Perfect. So we have at -2 and 2 and at -1/2. Will the graph cross or bounce at those points? Well, because the multiplicities are odd, yes, they're going to cross. Look at the factored form. Look at the multiplicities. If they're odd, they're going to cross. If they're even, they're going to bounce. So what can you think about the basic shape of the graph is going to look like? The degree is what? And A, the leading coefficient, is positive. There's no negative sign here. Oh, that's what you meant by sideways S. I thought you meant something like this. Okay, yes. Okay, yes. You're absolutely correct. It is a sideways S. I was thinking more like a squiggly M, like the New Balance symbol. So since it's positive, we know it goes up on the right and down on the left. Since the multiplicities are all odd, what happens at each x-intercept? Do they cross or does it bounce? It crosses. So we know this has to happen. And it crosses at -4 here. So there's the basic shape of the curve. The further apart the x-intercepts are, the deeper it goes. The further down it goes. And there you have it. There's a rough sketch. Of course, you'd have to plot some points to get a better accurate picture, but there you have it. Okay, this one. Sketch this one. X to the 4th. Let's see if am I still taping. Yes. Minus 7x cubed plus 12x squared plus 4x minus 16. In a week, you're going to be able to factor this out yourself. By next Wednesday, you'll be able to do this yourself. But for right now, I will give you the factors. All of these, those are going to be our samples next week when we start learning all the procedures. So what's the degree? Yeah. 1 plus 2 plus 1, or look up here, that's degree 4. So it tells me, is A positive or negative? Yeah, the leading coefficient is positive and a degree 4. So what does it tell me the graph's going to look like? Yeah, both ends going the same direction, both ends going up. So our zeros are where? It's opposite sign. So +4, +2, -1. So at -1, we have an x-intercept. At 2 and at 4. Okay, what happens at x equals -1? Is it bounce or cross? Yeah, because its multiplicity is 1, we know it has to cross. At 2, what happens? It bounces. Bounce. And it crosses at -16. And at 4, what does it do? There you have it. So the hardest part's already done, is you figured out what the graph's going to look like. I mean, yeah, the shape could change a little bit because of all these other numbers, but this is the basic shape. But it has to go down to -16 because that's the y-intercept. So this one has 3. So this one, in reality, this one only has 2 spaces, has 3. So this one will look a little bit lower than that one. In reality. Everybody feel so good so far? So the hardest part is once you factor it out, each of those parentheses parts tell you a lot, whether it crosses or bounces at that point, and how many times it happens. The last thing in this section, the intermediate value theorem. What the intermediate value theorem says, we have a continuous function, continuous polynomial function P. We have 2 points, A and B, where A does not equal B. They have to be separate points. What it says is this. If the signs do not equal, if the sign of P of A does not equal the sign of P of B, what is that going to tell us? In other words, let's say at P of A, the answer is negative. And that means at P of B, it's positive. Remember, it's a continuous function. So between these two, what has to happen? We have to have an x-intercept, at least one. So if you have a continuous function and at 2 points, if they have different signs, then all it tells us we will have at least one x-intercept between those 2 points. Because if one of them is negative, the other one's positive, the only way you connect them is by crossing the x-axis. That's what the intermediate value theorem tells us. Okay, here's our function. And the first one, A equals 4, or -4, and B equals -2. A equals -1, and b equals 3. Let's see how this works. In other words, what this is asking, is there an x-intercept between these A's and B's? Is there going to be an x-intercept? Will it cross the x-axis between this A and this B? How do we figure that out? G of -4 is -4 cubed plus -4 squared minus 6 times -4. Negative, negative, negative is a negative answer. 4 times 4 is 16, times 4 is 64. Negative, negative is a positive. 4 squared is 16. Negative times negative is a positive. 6 times 4 is 24. (16 plus 24 is 40. Negative 24. So at -4, the answer is negative. Let's try it at -2 now. G of -2. -2 cubed plus -2 squared minus 6 times -2. Negative times negative, this would be negative. 2 cubed is 8. -2 squared is positive 4. 6 times 2 is 12. -8 plus 16 is positive 8. So what can you tell me about -4 and -2?
Right.
That's not what it's asking. This is the intermediate value theorem. Look at your notes. What did you write down for intermediate value theorem? If the signs of the two values are different, one's positive, one's negative, that means between A and B, there has to be an x-intercept. So between -4 and -2, since there are different signs, there's at least one of the numbers between -4 and -2 that'll give us a 0. So there's at least 1 0 between -4 and -2. How about at -1 3? Six times -1. -1 cubed is -1. -1 squared is positive 1. Negative, negative is a positive 6. Those cancels, we have 6. So at -1, it's a positive answer. At 3, (3) cubed is 27. 3 squared is 9. Minus 6 times 3 is 18. 36 minus 18 is 18. So what can you tell me between -1 and 3? There are no x-intercepts because they're both positive. They're both on the same side. And that's what that says. Any questions? Comments, threats, bribes? That does it for section 2. I told you all it's going to be, chapter 4 is going to be the hardest one. And this is the easy stuff. That's why I need you guys to stay current with this stuff. There's a lot of moving parts. In the next section, I teach you guys how to do division of polynomials, long and synthetic. Yeah, you say, what the hell is synthetic? It's fake. All right, so that's it for today.